Okay, hi guys, so we'll be continuing from the previous lecture wherein we were seeing how to calculate the age of rocks and minerals, in which we were seeing a reaction like uranium 238 got disintegrated into lead 206 82, or better let's call it 82 lead 206, okay, plus let's say x dash moles of 2H 2 helium 4 and y dash moles of beta particles. So you are looking that after time t we were having uh, W grams of uranium and Y grams of lead. Okay, so we need to calculate the time at which this configuration is there, in which we have W grams and Y grams of lead. But before that, let's talk about how what is the stoichiometric coefficient of helium particle and beta particle. So herein we can see that I'm just generalizing that for any atom X having atomic number Z and atomic mass A, we can write that if this X dissociate or emits a helium particle, let's say X dash helium particle, which is the same stoichiometric coefficient as in the previous case or as in our example. So helium is having atomic number 2 and atomic mass 4, okay, and we are also having another atom X dash, in this case lead, having atomic number 82, or simply let's say it would be Z minus 2, because Z minus 2 from X dash and 2 atomic number from helium will form atom X. And similarly for the atomic mass, we can write that the atomic mass can be written as A minus 4, because the rest of rather this would be Z minus 2x dash, rather let me just write it that it is overall 82 and 206 atomic mass is found. And similarly, if this X dissociate into beta particle, which is in this case Y dash moles of beta particles, then we can again write it disintegrated into lead with atomic weight 206 and mass, rather atomic mass 206 and weight 82. From here we can write that as beta particle is not contributing to the overall mass or overall mass A of the uranium 238, only helium particle is contributing, so we can write that 238 would be equals to 206 plus 4 times X dash. Similarly for the weight, we can write this was the weight for the atomic mass 92 is getting converted into 82 atomic mass, atomic number of X dash, and how much is helium contributing to X dash and how much beta particles contributing minus Y dash. So from these two equations we can calculate value of X dash and Y dash. So value of X dash will come out to be 8 and value of Y dash will come out to be 6. So we can replace 8 and 6 here. So uranium 238 dissociates into or disintegrates into lead 206 and 8 moles of helium 2 helium 4 and 6 moles of beta particles. So now at this point of time we know that W grams of U238 is present, and let's suppose we actually get N moles of helium after time t. Okay, so we can write that if we get N moles of helium t after time t, okay, so we can write that N by 8 moles of uranium 238 must have been dissociated for in the time t, so that to convert or to produce n moles of 8 helium 4. So we can write that, let's say initial moles of uranium 238 were n naught, okay, and moles at time t would be nothing but n naught minus n by 8. Okay, these many moles would have been there at time t. Why? Because from 0 to t, n moles of helium were captured. So moles that have been dissociated of U38 from 0 to time t would be again n by 8. So moles remaining would be n naught minus n by 8. Okay, and we already know that I've just abstracted it in the terms of a variable, that we got y grams of lead, but so as to calculate the weight which is present at this point of time. So this is the mole which is present, and this should be equals to weight of, or better we can also write it like n by 8 would be equals to rather y grams which have been captured divided by 206. So from here we can calculate the value of n. Okay, we will already be given in the question the value of n naught. Value of n can be calculated from here. So we can calculate time period t or time t as 1 upon lambda ln n naught upon, this is moles after time t, so let it be moles after time t, or nt would be equals to, let's say this is nt, so nt would be equals to n naught minus n by 8. Okay, so we can calculate the time t which has elapsed for the disintegration of uranium 238. Okay, so now let's see emission of particles like alpha, beta, gamma. So emission of certain particles with the conditions and effect. The conditions and effect. Okay, so let's say we are talking about emission of alpha particle, which is 2 helium 4. So the condition for this to occur is, so first of all let's write what is the equation for the disintegration. So suppose we have an atom X with atomic number Z and atomic mass A. So after disintegration, let's say it forms at another atom with another atom X dash. So plus it also emits helium particle or alpha particle. So in here what we can see that the atomic number of this X dash would be reduced by 2. Let's say one mole of, or one alpha particle is emitted, so it would be Z minus 2, and atomic mass would have been reduced by A minus 4. Okay, so example of this can be, let's say we have U238, so it emits, let's say one atom of U38 emits, let's say one alpha particle, or we can also say that 1 mole of uranium 238 emits 1 mole of alpha particle. So we can say that it is getting converted into thorium with atomic number 90 and atomic weight 234. Okay, so conditions for this to occur is Z for any atom that is emitting alpha particle should be greater than 83. Okay, so this is the property of heavy nuclei. Property of heavy nuclei means only heavy nuclei can emit alpha particles, and effect would be N by P ratio increases. Okay, what do I mean by N by P ratio increases? So here if you calculate the N by P ratio, so N here would be atomic mass minus atomic weight, which is 92, or which is nothing but number of neutrons, which is number of nucleus, or number of, this is not number of neutrons, this is number of total number of nucleus plus, or other, let me write it. This is number of neutrons plus number of protons. So, and this is just the number of protons. Okay, so if we have to calculate the number of, just the number of neutrons, we have to subtract 92 from atomic mass, or total number of neutrons plus protons. Okay, and divide by 92 would be number of protons. Finally, we would be getting number of neutrons divided by number of protons. So this ratio increases because this now U238 is now converted into thorium-234. So now the new ratio would be 234 minus 90 divided by 90. So this ratio increases. So with this, we come to the end of this lecture. In the next lecture, we'll be seeing emission of more particles like beta, and what are the different conditions in which the trigger of beta particle emission would happen. And then we'll also be seeing emission of gamma particles, positron, and then we'll be seeing more on, or rather more examples on the same. So till then, good luck and goodbye.